Okay, my friends, I finally figured out. The reason we were able to split the light is because of a jackhammer effect. And the jackhammer effect is this right here. It's nothing more than a device that's going up and down. And watch what it does to that concrete. Look at this. That is what we did with a pulsed red laser. The pulses are the jackhammer effect. Okay, you should be able to do this at home, and maybe you will become the next billionaire, because we need free energy to save the world. And how are we going to get it? With pulse lasers through a Venturi slit. This is the key right here. This is the key to everything. And why do I say that? Because this is nothing more than shooting out boop, 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 a pulse red laser. That's as powerful as it gets until we put it through this Venturi. That's the Venturi right there. That's the device. There's two little round pins, and it has to be set at an exact tuned distance, and the diameter of the pins, I'm sure, has something to do with it, whatever. This was exactly what Rod Warren did 6 or 7 years ago. And I worked with him for years, and it took me a long time to understand this, what was going on. But it ends up being, it's the pulsation of the jackhammer effect of the pulses of light, because that's how they measure the distance, and they pick up how far it is away. And these are very short pulses. So what are they doing? They're hitting, and what is banging? The black particles. And what are the black particles? This is a wave. A wave is only created because there is a particle in the center of it with a big magnetic field around it. So it has to impress itself against everything else. It creates a wave, but it's really a particle. And the particle is this particle right here. You see it? It's what they call a 2p2h. There's two white particles and two black particles. This is a downspin. That's an upspin. The leading edge is what they call a spin, up or down, and then this is a photon. Half of this would be an electron, and half of an electron is a muon or an electron neutrino. And let me show you those occurring. And we show light speeding up, light slowing down. You see it's wider here, slowing down there. So we know it can speed up and slow down. We know Einstein was wrong. We know now that light is a particle, and we can see that just before it concusses, this is the configuration. At the concussion, it divides, and the division is right here, which is this right here. The black ball is the muon neutrino, and the white ball was the electron neutrino, now turned into electron showers. And here they are right here. And this is exactly what CERN wants to see. This is not my doing. They want to see the black ball, the muon neutrino, stay the black ball when it concusses and turns into Cherenkov radiation, and it just goes on its way. The electron neutrino turns into a shower because it forces against every other electron, and everything has electrons, and they just turn into showers. That is what I just showed you right here. The black balls do not change their size. That's why the white ones can squirt down and get through the Venturi. This is the key right here. And all Rod did was put a circular nail there and one right there. This is literally, and I'm not kidding you, this is all he used to do everything I just showed you. This is it. And he used, well, he had to use two little nails too. And that is what's called a Venturi. And it's a slit. That the light has to come through there and force its way to get through that slit. And the black balls just keep hammering that light through until it forces it to squirt out the other side. This took me a long time to figure this out, but I'm pretty sure I got it right now. The black balls will never change. They're dark matter. That's why they're so much heavier than the white balls. The white balls will squirt down and charge up and squirt and all that stuff. So what we need to do is use this to get free energy. And this is not a big stretch. We're looking at it right here. And here's what we got to do is make that turn into extremely energetic particles, which it is, and then harvest them with a solar collector, but a good one, you know, something we use transition metals. But they don't even, this is cheap, absolutely dirt cheap, free, dirt cheap. You carry it in your hand, carry it around, plug it in. You don't need any grid. You don't need anything. You create any energy you want. Then you filter it and do what you need to do to create AC, DC, whatever you want. 50 cycles, 60 cycles. Once you get it here, And you start pumping it down. You do anything you want after that. And you can make cars and trucks and lights and heating and air conditioning and pumps and save the world, save the people. You can do this at home right now. Somebody's got to figure out how to tune that Venturi and get the same results Rod did. And all he did was hold the selfie portion of this exact same phone, the Samsung Galaxy S3, and he used a Bosch construction labor. And he's using all kinds of different things now. But he lost the tuning of this Venturi, and we can't seem to get it back to in tune. So somebody needs to have a little money, a little time, and just do it. This is simple. I'm serious. This is what you see right here is a division. That's fission, that's fusion. Done with exactly what I am holding in my hands. Please, somebody do this. I've been blocked from being allowed to show this. The people that are spending literally billions of dollars, probably a day, will not allow this to be seen because it's an ego situation now. This ego has nothing to do with this. I don't want anything. I don't even care if they ever mention my name. I just want this to be known that this is possible. We can help the world. Insanity not to let this be seen. Very, very distressing. Okay, these are the white balls, and this is the black. The black don't change. They're never going to change. They don't absorb, they don't emit, they don't concuss, they don't reflect. They do nothing other than re-attract to the white. That's all their mission in life is, to get a hold of one of these and hold on to it. And that's dark matter, muons, bosons, whatever you want to call it. These would be the fermions. Those are what I would call electrons. And this... together, two electrons, back to back, or two little bar magnets, create a photon. This will bounce from you. If you just have one of these, it's electricity, it's a sparky little bugger, and it'll burn you. All it wants to do is get back to ground. These are already basically grounded. They're in a neutral configuration. One of them at a time, that baby wants to attach to something. That's why electricity on its own, which is that, will hurt you. This, they'll warm you up a little bit and bounce off you and light you up a little bit, but they're not going to kill you the way electricity will if there's enough of them. So this, can you accept this? This is what forces and squirts through the Venturi. Once more time. Again, this is the two of them attached together. That's a muon and an electron neutrino. That is a muon and electron neutrino. They are nothing more than bar magnets. However, I would have never suspected, but they can actually separate. And they do. And we did it. And here's where they actually separate, right at the Venturi. So that is fission. That's fusion. And that is precisely what they want to do to create free energy. And there they are. There's a muon neutrino, electron neutrino, the muon, the black ball, the electron shower of white. Can you accept this? Can you allow yourself to see this and understand? And if you can, you'll understand that we can do this within a matter of days, because this is a very, very, very simple device. Absolutely as simple as it gets. Let me show you, and then I'm going to let you think about it. All right, don't tell me I can't see these particles with these laser lights and the cell phone, because this has CMOS. This goes back to the same time Rod and I were doing these experiments. Again, this is all you need. You don't. Most people probably won't even have to buy anything hardly. A lot of people have these little, and these are cheap, little measuring lasers. But this is what they did. They found that they were looking for cosmic rays, which are extremely energetic subatomic particles, exactly like I'm showing you. What I'm showing you are extremely energetic subatomic particles. They're light, and they are excited light. When those particles crash into the Earth's atmosphere, they create showers called muons. That's exactly what I showed you that we created and Rod created with the Venturi. Now, if you could tune this Venturi correctly, and you get all the little technical details of the Venturi, you're done. That's all you need to do what we did. This is as cheap as it can possibly be, self-sustaining, solid state, portable, handheld, extremely reliable, extreme energy capacity. And you know, you just use a little tiny bit of it to refeed the laser, and it just keeps running and running and running forever. Something like this you carry around in your hand. A couple little dials or whatever you need, little buttons that tell what kind of power you're going to use, and plug in and off to the races. Out in the woods, disaster zones, pumping, heating, air conditioning, lighting, driving, shipping, free. Now, that's the only way to save the planet right now. There is no other way. Zero other way. We are in deep, deep, deep trouble. And the more we burn, the more the gases blow up. That's what's heating our atmosphere up. That's what global warming is. That's what leads to all this turmoil. And you know, as the Earth spins, it's spinning into more and more particles that are just flumping up like a hard balloon now. It used to be sort of a soft balloon, sort of work its way around, but now it's just, and you get your tornadoes and hurricanes and compressed air, condensation, and it's where it hits the Earth's surface, coming off the oceans, and it's smacking into there. That's why we're having all this flooding and terrible, terrible situation right now. This is the only way out. Okay, my friends, this is Roger once again. Today is an extremely important day, and this is Google, and they say we must help build a more sustainable future for everyone. Absolutely, and I mean quick. At Google, which I love Google, I use it all the time, obviously. I Google everything. At Google, we remain committed to sustainability and continue to lead and encourage others to join us improving the health of our planet. Now, they have, boy, I think they have like 30 people working on, they're talking about decarbonizing. Now, I say it's not the carbon they really have to worry about. It's the expansion gases, all of them, not just the carbon. And I'd love to engage with these people because I believe I have some very important information, but something else that Google does is I think they put me on a spam list. I mean, I have people on spam lists, yes, absolutely. But I've been put on spam lists by virtually all of academia, and you know, anybody that they think I'm crazy. They thought I was crazy. Now they realize I'm not crazy. They're the ones that have been pushing back against me so hard that I've been pushed off of the planet, basically. I'm a man without a country at this point. I can't get in touch with anybody to try to help our situation. Okay, this is the article from Google, or by Google, I guess, about what they are doing. This is in May of 2019. Google revives controversial cold fusion experiments. Now, what the problem is that they're working with atomic particles, atoms, full-blown huge atoms of I think they're using palladium and then tritium and so forth, but these are full-size atoms. In other words, they're like this. They have a ton of little particles. I mean bazillions of them, millions of them. We are using this. All right, we're using light, which is already the smallest particle that we know of, except electricity, which is just one step under light. And then now we realize that we can create the muons and the electron showers right out of light, which is photon fission and fusion. And that's what they're talking about here, cold fusion. All right, you see this? Cold fusion. This is what we did. Now listen to what they have to say here. Notorious claims. In 1989, two U.S.-based chemists announced they had seen excess heat and fusion reaction products. And they did again in 2013 at Cornell from the 2P2H particles, which we created. I'll show you, and I've shown it 100 times. This was signs of nuclear fusion when they ran across two palladium plates and water laden with deuterium. That's what I mean. We don't need to do any of that stuff. We're just going to use light. Others quickly pointed out the errors in their procedures and da-da-da. But cold fusion, now commonly referred to as low-energy nuclear reactions, exactly, has retained a persistent following that continues to claim evidence of success. That's right. Cornell. Well, right here. Here it is right here. Neutrino interaction generators. Understanding the so-called two-particle, two-hole, which is 2P2H effect is an urgent program in neutrino interaction physics. Such processes are believed to be responsible for the event excesses, that means increased energy, free energy, observed by recent neutrino experiments. This is 2013. Now, hold on, where was I? All right, here it is again. A new nuclear radioactivity. Muon emission during fission. I showed it. All right, this is why we can do cold fusion. We don't have to break apart gigantic chunks. We just shot light out of a laser. Very simple, very easy. It concusses with every particle that is in the air because they all have electrons, just like this particle does, which is light. And this is that particle right here. And just before it concusses, it displays. You never ever see this particle ever until it gets ready to explode. And when it explodes, here's what happens right here. There's the particle being sucked out of the wave because of this Venturi. And I have discovered, I think the reason why is because of the pulsation of the concussion and the forcing of the white particle through the Venturi, and the black ones can't go through. But it has to be tuned exactly correctly. When this was originally done 6-7 years ago, we worked on this quite a bit, and we could see these particles accelerate. We could see all the Higgs fields. We could see everything about this. And then we could see this, which was the muon and the bosons, and the split, which was the muon and the electron neutrino, the black and white ball, creates the muon, which is the black ball goes on its way, the white one turns into the shower, and here it is. Now, I tried showing this to everybody in the world, literally everybody, I'm not kidding you. I even took a course at the University of Geneva, particle physics, so I could get in there and showed it to them, and they looked at it and they said, ooh, this is nice, and that was it. Nobody was interested. Will you please look at it? And nobody would. So what can I say? This could be free energy right here. All you got to do is tap into this and bring it back to these black particles, and you got a loop of electricity that should be forever and never have to stop, which means free energy. And this is here it is right here. You saw the particles attached together here, and they're only light. So here's the key. Fermion and CERN and all those people, they think everything has to be starting from protons and big chunks of matter and slamming them together, and then they dig through that debris and they see these things. They say, wow, look at that, we see all these all the time. Wow, I wonder where they came from. Well, they're elementary particles. But then they say, well, sometimes they spin up, sometimes they spin down, sometimes they're two bangers, sometimes they're four bangers, sometimes there's a one, sometimes there's this, and they name them all quarks, tetraquarks, leptons, muons, bosons, fermions, it's phonons, it goes on and on and on and on. They are only, hold on, I got my little thing here, which shows you electron flood theory. Every one of these is made out of an electron. Two electrons together, which are nothing more than a bar magnet, have a weight, it's very, very tiny, and 1,839 of those added together equal a proton, which is in the nucleus of atoms. And it seems to be stable at 1839. I can't get, it's got to do something with the vibration and the push to shove of all these little particles. At 1839, they say, okay, we could stay together in this little ball, but if we add 4 or 5 more, we'll become an isotope. And they do. And that's why they give them half-lives. They say it's stable at 1 or 2 extra particles. And then at 3 or 4, they may not be stable and fall apart within, they call it the half-life. And they can only stay stable for so long. He doesn't want them. Get out of here. Go. No, I want to stay. Get out. And at a certain time, basically, they leave. They can't hold them anymore. So that's what half-lives are all about, and that's what isotopes are all about, and that's what nucleuses are all about, and they're made of nothing more than electrons. Photons are made also of nothing more than electrons. 2 of them spit out from crystals and things that shot out, escaping the nucleuses that they're attached to, is light. That's what light is. It's a stimulation, so stimulated that they shoot these little extra particles that are hanging around all outside here. They pow, and they go out. And I've shown this with tractor beam magnets. Look it up, Bruspup tractor beam magnets. This is, that's fabulous. And then look up the salt table experiments, and that shows how these form in patterns, and you'll see it's absolutely stunning. And it's all up to do with vibration. The more the vibration, the more intricate the patterns. Okay, so I have shown you that we're seeing these muons and these electron showers, and that's the 2p2h particles that I showed you, and we can actually see them. Now, again, I cannot recreate this. This was just an exceptional, accidental thing. And that was 6 years ago, and we just don't have time to keep playing around with this. They're given $10 million to test cold fusion claims rigorously in a field that lacks credibility. Scientific data, this guy says. Another goal was also to push methods in challenging experimental conditions. That's what I want, is to test this. Please test it. Anybody that knows anybody at Google, if you know Mr. or Mrs. Google or whoever the Google kids are, see if you can get them interested in this, looking at it. I don't want anything. Rod, I don't think, wants anything either. Somebody should compensate him for all the time he put in on. To me, I don't need anything whatsoever myself. That's just another issue, and it's just not my goal. And it's not Rod's goal either, so don't get me wrong. But I was very, very pleased to have his help, I can tell you that. Otherwise, I could never show my electron flood theory, and we'd just be walking around in circles for 1,000,000 years. Anyway, they want to do challenging experimental conditions. All they have to do is adjust that Venturi and create it just exactly the right way, the right distances here and the back, and then receive it just like a solar panel, and we're off to the races. It says, but he adds, the fact that the payout could be huge is definitely a component of our interest. Because they've been laughing at it, so to speak. They say that it's kind of silly to do this. There's no evidence to support it. And, you know, there's some, like, fringe people that are into this cold fusion. And they got 30 people working on it, I think. You know, and I can't get through to anybody. Google team explored 3 experimental setups, but they're all using palladium and hydrogen. Yeah, they could do that. I don't disagree with that 100%. I haven't looked into this very deeply. I see what I see, and I can do it for almost zero. Literally almost zero. We're talking about this in a cell phone, a little pulse laser, and you saw the increase of energy. It was just staggering. So, and they want peer-reviewed journals and all this stuff, or they won't talk to you. And that's exactly what they told me. Everything was peer-reviewed. 30 years ago, 50 years ago, I was talking about this, and they wouldn't. Well, I didn't know how to do it back then. I had no idea. But it says Google has been funding experiments into continuous science for cold fusion. The theory that nuclear fusion, the process powers the sun, can produce energy in a tabletop experiment at room temperature. Showed it. 2 scientists first made sensational claims about achieving the phenomena, promising endless cheap energy 30 years ago. But their results were quickly debunked, and the topic's now considered scientific taboo. Exactly. This is what happens. Instantaneously, they destroy you about everything. I have not had one single scientist ask me one single question. All I've had is denials and don't get back to us, and I've been blocked by Fermilab. Don Lincoln and I did not get along well. And he said, I won't look at a single word you have to say. You're not peer-reviewed. That's all you see. Peer review, peer review, peer review. Well, that's how they keep doing it. Revealed, peer-reviewed, blah, 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 blah. Well, no evidence for cold fusion is possible. Well, guess what? I have the evidence, and they refuse to look at it. It's taboo. All right, let me just end it right here. This is the key right here. The compression of the jackhammer effect. Here, where the black ones can't get through this exactly correctly tuned Venturi. And there's going to be a million different styles that you can do here. There'll be V-shaped ones, there'll be rounded ones, there'll be vortex-looking things. They can do all kinds of things with this. Copper, zinc, aluminum, whatever. Because they all have different energetic electron layers. There's a lot of playing around you can do. But right away, we saw that rod could do this. There was no question whatsoever that it was fission and fusion, and nobody can deny that. Unless you're just a denier of reality. And that's what I'm getting from academia. They just won't allow this to be seen because it really kind of embarrasses them. But this is all you need to create desktop cold fusion, which is the holy grail of energy. And this energy right here is so much more energetic than regular electricity because this is only the electron portion. It doesn't have the muon attached to it at this point. So it wants so desperately to get back to that muon that its energetic value here is just absolutely stunning. And this is what we could do with a little handheld device. I can't see it. You should be able to power your house, every little need you want. Refrigeration, air conditioning, heating, lighting, swimming pools, water pumps. No grid. And we need to get this done right away. Right away. Okay, I hope you understand, and if you don't, just keep following my stuff. The electron flood theory says there's nothing more than electrons, and 2 of them make a photon, and 1,839 of them in a ball make a proton. Now, here's what they're saying right now. Physicists don't know the mass of a neutrino. I don't either, but now they say it's no larger than 1 electron volt. Well, how do they know that? Every time you see something, it says totally unexpected. Well, guess what? Then they say this, which is absolute nonsense. Standard model particle physics is one of science's most impressive feats. No, it's not. It doesn't even account for gravity. Gravity is absence because so far fitting it into the standard model has been extremely challenging. Well, because they're saying, oh man, it's unbelievable. All right, I'll just leave you a couple quick things. Now, don't forget, we can do all these things with what I just showed you right here. We can create desktop cold fusion. Now, they see all of these particles, and then they think they're all separate, different types of particles. They are not. They are all made of electrons. We can get down to the electron neutrino and the muon neutrino and separate those into the muon and the electron showers. I showed you this without question. So all of this is meaningless. But you should look it up and study it. Now, let me show you a couple other quick things. All right, this is really serious to understand because look what it says. Although lasers range from quantum dot, like the tiniest little dots, to football-sized lasers, and utilize materials from free electrons to solids to gases and all kinds of things. My brother ran lasers at Pratt & Whitney, drilling holes in vanes for the turbine engines. And he actually developed a process to keep the after splash. When they drilled through the veins, into a cavity, and then there was a splash came, and then they were having a hell of a time figuring out how to deal with that splash. Guess what he came up with? He used candy. They melted candy and put it inside, you know, like the inside the veins, and I guess there was enough of carbon or whatever was in there, I don't know, but the splash ended up going into the candy. They melted it out and everything was fine. But anyway, there's very simple processes to almost anything, but you have to understand the basics. This is the basics of lasers, and I mean this is not basics, this is lasers on steroids. They go through all the different types of gas lasers to ruby lasers to YAG lasers. That's, I think, my brother Ronnie, who's coming over today, ran, and this goes through, and what we want is that pulse laser, and that you can create all kinds of different types of pulses, speed of the pulses, and they're using mostly titanium sapphire lasers now, but this is just opening up. This is, well, see, this is what we need, pulse lasers. Anyway, I'm going to leave you at that. That'll give you enough to get started. You have to understand the lasers we use, it was it. This is it. This pulse is fast enough. Now, maybe it's got to be just as fast. Maybe it's got to be twice as fast and give it twice as much energy. I don't know. But I'm going to tell you one thing. The energy I saw was no question. We had a hell of a lot of energy coming back from a very little put in. Don't forget, that's all it would have been until we shot it through that Venturi. And at that point, we got, that is just explosiveness on steroids. It's that's called a reverse EMF. It's coming backwards, forwards. This whole ball, if we can encircle this whole thing and just put a little hole for the laser to come into, and then encapsulate it with like a solar panel, but in a spherical form, we can capture all that energy and bring it back to use it for whatever we want. So we can make these devices really tiny to get absolutely enormous amounts of energy back.